Эмми трастит.
I mean, there we go. It didn't work first try, but hello everyone, and welcome to another stream. About that, bet you didn't expect that shit to happen. Hello. Yeah, double pop today. We did a double pop. So today is Friday, and that means today, according to the schedule, we're doing a random one-off stream. How about that? Hello, Strip Back. Hello, Dusk on Clips. I good do Klambakota, Essenti, Kolumbetka, Essenti. Hi, I don't see any new people. We have only a fixed amount of people here. Benny Darshan, hello, welcome. So, I haven't been following along. Good haircut, yes. So, yeah, essentially, this is my new look from now on, and that's the explanation. Hello, Linux 92 numbers, Joshi, hello, Jobi, hello, welcome. So, today is Friday, as already mentioned, and that means today on your schedule we are doing a random one-off stream. And the topic of today's stream is spam filter in Haskell. So yeah, that topic was inspired by Erica M on Discord, and here she's stripped back. Thank you very much. She was implementing like a spam filter for Discord using a naive Bayes classifier, and since my university was such a shit, I never learned about such techniques. So I decided to make up for that on my streams and learn about that on the Friday stream. So yeah, thank you so much for inspiring today's topic. I didn't read much about that technique, so I just read like a very very concise Wikipedia article. And I don't want to read anything else on that. I want to just try to derive the solution off of that Wikipedia article. So don't expect anything particularly educational out of that stream, because I'm going to pull off this solution for this classifier out of my ass, literally. Not literally, I mean, it's against 2s, but so you can just keep in mind that I have no idea what I'm doing, right? But I kind of get the whole, like, the general idea of how to do all of that. So, and that's essentially how we're gonna go today. All right. So, already triggered. I'm sorry, Lost Algorithm. I know that you're doing that like professionally. But yeah, I'm probably gonna make a lot of mistakes, and please forgive me for that. By the way, hello Lost Algorithm, welcome. So let's get started. So what is naive Bayes classifier? So there's like a whole Wikipedia article on that apparently. So naive Bayes classifier spam filter, like there's literally a Wikipedia article dedicated to that. Yeah, so there's a separate article about naive Bayes classifier and specifically application for spam filtering. And it doesn't really explain much, except this formula. I think this formula is the most important part of this article, and this is essentially what we need to implement. Right. So has anybody heard about Bayes theorem? Even though my university was shit, I still know what it is because we had a course on probability theory. So of course we learned that formula because this formula is very important for probability theory. And yeah, it looks like this. I mean, we can take a look at the proper rendering of that formula. Yeah. So essentially what that means, like, what is this notation, right? So we have this notation, P stands for probability. And what is that? So A and B are different events, right? So what this entire thing means. So this is a probability of event A happening given that event B has happened. Or in other words, A being true given that B is already true, right? And this is the formula, if I understand correctly. So essentially it's equal to probability of B being true given that A is already true multiplied by probability of A divided by probability of B. So and that's the whole formula actually that is used in the naive Bayes spam filter. So and this is how they do that, right? So on the left, excuse me, on the left here they have a class. Right. Since it's a classifier, what is a classifier, by the way, right? So essentially, you have a fixed amount of classes, right? And class could be like a topic or a theme of the text, right? So in case of a spam filters, you have only two classes, spam and not spam. By the way, while researching this topic on before the stream, I did a little bit of research. I didn't implement anything, but I just skimmed through the articles. Apparently, in the industry, the opposite of spam is called ham. And that made me laugh so fucking hard. Like, I didn't know that. It's so fucking funny, right? So, yeah, something that is not spam is a ham. God fucking damn. And by the way, this is why they have a probability of H. It's a probability of the message being ham, and S is a probability of the message being spam. Jesus Christ, this is so funny. Like, I didn't know that. It's just... that's really clever. Anyway, so in case of a spam classifier, you have only two classes, spam and ham, right? So, but I think you can generalize that even to more classes, and we'll get to that a little bit later once we implement like a spam classifier, because I want to implement something like that for our bot, right? Maybe it will have a capability of classifying messages like a weeb message or backseating message or so on and so forth. We can have like a different common classes for the messages in the chat, and maybe we can assign a particular actions or on encountering a particular class of message, right? So bannable weeb, I mean, we're not going to ban weeb messages, but maybe do something interesting with that. So you can expand that idea even further. So, and how that works, all right. On the left here, S is a class, right? S is a class, and W is a word that is present in the message. So usually these kind of classifiers, they use a model called bag of words. Have you guys heard about bag of words? Yeah, here it is. So here's a bag of words. It's actually a very dumb model, but essentially you take a sentence and just build a histogram of it, right? So essentially you build like a multi-set, like for each word you just associate amount of words in that sentence, and given this table you can easily calculate the probability of that word being in that sentence, because it's basically the amount of the words divided by the amount of the whole words in a sentence, right? Bag of words. Is my pronunciation that bad? Words. Anyway, I don't speak English anyway, and listen, trying. So probability of the whole message being a spam, given that it contains word W, right? So we have a message, and probability would be in spam if it contains this particular word. What is it equal to? What is it equal to? It is equal to probability of that word being in the message if it is spam. So it's opposite of this one. It's actually quite important. This is opposite of this one. So probability of the message being spam if the word is in there, and this is probability of having that word in the message if it is already spam. So we're assuming here that it is already spam. And what's the probability of that word being there? Right. So the next one is the probability of, like, the whole probability of this message being a spam. So what does that mean? So this thing can be hard-coded. This entire thing can be actually hard-coded, and they even talk about that here. So basically it's like a general statistics. So generally we know that 80% of the messages are spam and 20% of the messages are ham. So you can basically treat PRS and PRH as the constants. So this is like a general thing, and that makes the formula look a little bit complicated. But what's funny is that there is a classifier called unbiased classifier, where they essentially assign 50% to probability of S and probability of H, which simplifies the formula dramatically. So yeah, you can basically remove these two constants, and this is the whole formula, right? So, and we're gonna work with that. Right. So we have a probability of a word being printed in the message if we know that it's already spam, divided by the same value. As you can see, it's the same value, plus the probability of a word being in the message if it is ham. And that's it. That's the whole formula. That's the whole formula. So, and what's interesting is that this is not enough. This is only for a single word, right? This is only for a single word. But messages contain several words, so you have to calculate multiple probabilities. And after you calculate it, after you know how to calculate probability for a single word, what you do is you compose these probabilities, right? So essentially, the whole probability of this message being a spam is this. So it's multiplication of P1 to Pn and this thing. And P is basically probability. P1 is probability of first word, P2 is probability of the second word, and so on and so forth. So you basically substitute to that formula, and yeah. But I'm not quite sure if I simply iterate through all of the words of the message or through all of the known words. That's the question. So I'm not even sure, but I don't think it matters that much, because it does not stop us from implementing this entire thing. So, okay, the question is, how can we know these values? How can I know the probability of a word being in the message if it is spam, and the probability of the word being in the message if it's ham? Well, it's quite simple. We just need to maintain, if I understand correctly, again, I just skimmed through the articles and I didn't read into them. You basically keep a track of 2 bags of words. Bags of word for spam and bags of word for ham, right? And with these bags of words, you can easily just calculate these 2 probabilities. Right, because you have statistics, and from statistics you derive the probabilities. You just put that into a formula and you get the probability of a single word, and then you go through all of the words and you multiply the probabilities and you get the probability of this message being a spam. So it's just basically calculating a huge formula. Okay, professional machine learning engineers, did I understand this thing correctly? I just read only a single Wikipedia article. Is the stream dead, or everyone is just listening to me? Okay. Wikipedia, by the way, yes, I'm testing. Hello, to Reclamo, welcome. So yeah, to be fair, it doesn't really matter if I got it right or wrong, because it doesn't stop me from implementing it. So I'm gonna implement it. Citation, okay. I'm gonna just implement it how I understand it, and we'll see if it works or not. We'll just apply whatever I derived from this article, and maybe the mistakes I've made would be obvious, right? Maybe it's gonna be completely wrong. Sounded fine, yep. You keep track of vocabulary words in your training data. Unseen words don't matter until you add it to a set of training data. Okay, so the only thing I don't understand, n. We iterating through n of the words. What are these words? Are the words of the message that we're currently classifying, or are they words of all of the messages that we know about? All of the words we know about. So what we are iterating, words of the message or the words of the of like everything that we've seen so far? I think it was your TF-IDF implementation in Haskell. That works well with naive base, at least a bit nicer than pure word indicator. Oh yeah, by the way, yeah, I implemented TF-IDF and it was also in Haskell. But I'm not gonna expand it, I think. Yeah, and the TF-IDF kind of has like a different purpose, right? So it was purely for searching things. Is probability of message being a spam? I guess P1 is the first word of the sentence. How does it feel to go bald? It actually feels quite nice, to be fair. I kind of like it. Alright, so let's get started. Alright, so I was thinking, how should we call the project? How should we call the project? So the most obvious and delusionally clever name would be to call it Hammer, but after googling this name, I realized that I'm not the only one who's that clever, because people already done literally that, apparently. Like there's literally a spam filter using base analysis that is called Hammer. So okay, so then I was thinking, how can I call it? Okay, so ham. Can I just take a word ham and translate it to Russian, right? So in Russian, ham is spelled like this. And the problem is that if you transliterate that to Cyrillic, it looks very strange. It looks very controversial. I'm not sure if I'm gonna call it like that. So yeah, this is how we call ham in Russian, by the way. We call it vet China. No, but it's not pronounced like that. It's pronounced Vichina. But all right. So maybe I'm not gonna call it like that. But to be fair, that would be such a cool name for a spam filter if you think about it. That's really interesting. Okay. But yeah, we'll wet China. Sounds a little bit better, okay. So maybe we're gonna call it wet China. To be fair, we can just use the like Cyrillic look-alike transliteration. I'm spending too much. Huh. So that means we can use. Oh, god damn it! No, whatever. So let's go with something else. Although that is not gonna. Yes. Bike shedding. Yeah, this is literally bike shedding. Hello, Sokram, Lit, welcome to the stream. So, yeah. I'm gonna call it the chain. I think it's gonna be. I think it's gonna be okay. At any point, I can just say it's Russian. It's literally Russian. Okay. Yeah. All right. So we're gonna do that in Haskell, by the way. I forgot to mention that. We're gonna do that in Haskell. So I think I will need some third-party dependencies. I think I'll need some third-party dependencies, specifically like text. Maybe I'm also gonna maintain the database because I need to store all of that in some sort of a database, and it would be nice to have something like SQLite or whatever. So yeah, because of that, I think I'm gonna go and start Cabal project. Yeah, but BTTB. Okay, Cabal new. I think this is how we do that. I forgot how to create a new project in. Is it version? Version 2 new. There is just new build, new style projects. Maybe it's just init. Compile. Oh, new. It's okay. I see. Is it just init? I don't quite remember. I think it's just init. Let's try init. Precisely Cabal init interactive. To be fair, I don't really want it to be interactive because I don't want to go through their quiz and stuff like that. All right, so this is going to be the Chinam. And what are the dependencies that we'll need? So far, I think the only dependency I definitely will need is text. What's up, fucking tonight? Welcome to the stream. What's up? And yeah, we're gonna add this one. Maybe I'm gonna just. Yeah, why am I using Vim? I don't understand. Oh my god. So this is gonna be text, but I'm not sure which text I want to use here. Which text do I have already in my GHC package? So let's actually do list. And one of the texts that I have, it's down there. It has to be down there. Wait a second. Okay, here it is. So this is the text that we have. So it's that. So it has to be greater or equal than that, and less than that. Okay, so that should be enough, and I'm gonna try to build the whole thing with Cabal. I don't know why it took me so much, because probably I haven't worked with Cabal for quite some time. M3 letter, version is 7 letters. Well, I don't know. So maybe we don't really use that word as frequently as English speakers, because the more frequent words usually are shorter, so people usually like naturally apply the I forgot the name. Okay, I'm thinking about solution. That's why I cannot think. All right, so let's try to implement a bag of words. What's the difference between version 2 and version 3? Is there a version 3? I don't think there's a version 3. All right, so we're gonna introduce a type maybe. So we'll need data map. To be fair, I think I should be able to do something like this. Huffman, yes, I forgot the Huffman. Yeah, thank you so much. Oh my god. I completely forgot about the Huffman. So we don't have containers, right? We don't have containers, so I'll have to find what containers can we use. Containers. Yeah, here they are, and we'll have to add them to the build as well. So it's gonna be Cabal. Okay, and this is gonna be that. Less than 7, and there we go. Can I just go to REPL now? So essentially we're gonna just use a map, just a regular map to you know, to build all that, to build the bag of words. So let's imagine that we have some text. Let's have some text. So something like this should be okay. I might as well just copy paste it here and maybe even assign all of that to some sort of a variable. There we go. So at any point, we should be able to split that into words, right? So here are the words. And now we need to collect that into a bag of words. So the easiest thing to do here would be to fold left, right, where we have an accumulator and a word, and then we'll have to add that word to that accumulator. And the initial thing is going to be an empty map, right? It's going to be an empty map, but we'll have to import data map as m. So an empty map is usually created like this, right? So the module map has an empty map that you can use, and the empty map is the initial state of our folding, right? And the question is, how can we fold them together, right? How can we fold them together? Well, it depends on what kind of operations we have for the maps. Data map. Oh my god, why it refreshed 2 times? I don't understand. So how do you insert something? So you can insert a particular thing. So there's this one. Insert with. I have an interesting idea, I think. I have an interesting idea. What if we do a very similar thing as we did with Markov? So we're gonna define our own type, new type bag of words, and maybe we're gonna call it something like this. As map, and of course it has to be something like bow to map, and it's going to be m map starting from t text to the frequency, and we're going to implement a monoid for this particular type. And essentially when you've mappened these 2 monoids, it will merge the statistics of these words. So it's going to be way more convenient. All right. So this is exactly what we did with the Markov model for the bot as well, right? Markov model was also a monoid, and you can easily create like a very small, simple monoid out of a single pair of words, and then you can fold all of the monoids into the whole table. So, and we'll also need an operation word to bow, which accepts a single word and returns you a bag of words. So basically it creates a single, like a bag of word out of a single word. So it should be pretty straightforward, because essentially you take that word and you say that this word maps to 1, and you construct a map out of it. So there you go. This is how easily you can do all of that. And then the question is how you can merge all of that. Well, we have a special operations to merge 2 maps, right? You have 2 maps and you can merge them. You can even merge them with very specific operations. Yeah, so let me try to implement all of that. So I'm gonna use Haskell mod. Hopefully it will tell me where I have errors and stuff like that, and we will be able to quickly go through them. So by the way, this has to be like this. T-text. I also need to import qualified data text as T. And do we have anything else? Maybe I should just call it bow. Like, I shouldn't capitalize the last W, because I mean I keep typing it as small, so I'm gonna do something like this, just simplify myself life. No advent of code. I'm gonna do advent of code if I'll have time after I implement all of that. We'll see how it goes. We'll see how it goes. Okay, M from list, and what does it say? Oh yeah, after you constructed this thing, you have to wrap it into the bag of words. And okay, so before you can implement a monoid interface for bag of words, you have to implement a semigroup for it. All right, and a semigroup accepts two bag of words, this one and this one. So what's funny is that we can actually, what's interesting, not funny, we can pattern match them and automatically unwrap them, and here we can merge them together with M union with, where we're gonna say that you merge the values of these things. Jay the developer, thank you so much for 3 months of tier 1 subscription. Thank you, and welcome to our bag of words club. That's right. So yeah, that's what we're doing today. We're trying to implement like a simple spam filter. So I'm gonna just merge these two, and I think that should be enough. But after that, you'll have to wrap it back into bag of words. There we go. And I think, yeah, we'll still need to implement the monoid, because we need like an empty bag of words. Makeover, nice. What do you mean? You're talking about my hair? Yeah, I guess. Do you like it? All right. So, and we also need an empty bow, right? An empty bow, and an empty bow is essentially just, you know, empty map. And then we need to implement a monoid for this thing. Okay. To prove that it's a monoid, we have to provide the neutral element of the monoid. And there we go. What's funny is that that's it. That's the whole thing. You know what we can do now? We can take the text, right? This text. I'm gonna put it here. Let S. It didn't work. I don't know why. I'm gonna try it one more time. Hopefully it will work this time. Is that because, yeah, it's something with the new lines and stuff. Okay, there we go. So I have a text. So then I can split it by words, right? Zoned out, and this is new to me. What does the semigroup type class do? It doesn't really do anything much. It basically interface for types that are semigroups. Or semigroups, I don't know how to pronounce that. What is a semigroup? Thank you, Ambercode. So semigroup is an algebra. So it's a notion from abstract algebra. It's essentially a system. Sounds like Haskell, yeah, exactly. It's essentially a system that consists of a set of elements, right? In our case, usually it's numbers, and a binary operation defined on that set, right? So, for example, all of the integers and operation plus form a semigroup, right? So, and for example, all of the integers and multiplication form a semigroup. So a monoid would be, for example, extension, or maybe not extension, but a more specific semigroup that also has a neutral element like 0 or like 1, right? So essentially, bag of word is a monoid, is a semigroup, because we have a particular set of bag of words, and we have an operation, binary operation defined on that set of bag of words that allows us to merge them, right? Because you can always at any point take two bag of words and just merge them together. So, and that's essentially what we did. We just explained to Haskell, okay, this thing is semigroup, and now all of the like operations that work with semigroups will work on bag of words. And I'm gonna actually show how that works. So yeah, and monoid is basically semigroup with a neutral element. A neutral element is the one that is, when applied with a binary operation, doesn't change the original value. For example, monoid integer plus 0, right? 0 is a neutral element because it doesn't matter to what value you apply the 0. It's always going to be that value. So you see, it never changes that value. Something like integer multiplication 1 is the same, right? It never changes it. All right. So, and I also sort of explained to the Haskell system that bag of words is also monoid, because a neutral element for bag of words would be an empty bag of words that doesn't contain anything. Okay, so why is that even needed? Why do we need to complicate it so much? And I am about to explain that. So let's split our sentence into words. We don't have a variable not in the scope as. Okay, so I'm gonna take this thing one more time and I'm gonna split this entire thing into words. There we go. Then I'm gonna map each individual word and turn it into a bag of words. To bag of words. And there we go. It doesn't show anything because I forgot to implement showable interface. Deriving show. There we go. And I probably have to recompile everything. There we go. So here we have a list of bag of words. So here's the list of bag of words, and each bag of word contains a single word. So we have a list of bag of words and it contains a single word there. Now we have a very interesting operation called fold, which is not available right now because I don't remember where it is. I think it's somewhere in the standard library. Let me check it out real quick. Fold. It's in data foldable. Okay, so let's import data foldable and recompile everything. Okay, so if I take a look at fold, it takes list of monoids and returns you a single monoid. Monoid is a system where you have a binary operation. What it does, it uses information about binary operation of the monoid and its neutral element to fold all of the monoids into a single one. You see where I'm going? See where I'm going? So now, here's the list of bag of words, and I fold all of them into a single bag of words. How about that? Using the power of monoids and semigroups. So that's why we need these interfaces, right? So essentially, these interfaces enable you with just, quickly define a bunch of small monoids and just merge them into a single one. And this is how we can collect the statistics. So, yeah. You should make a tutorial on Haskell someday. Maybe I should, yeah. Maybe I'll do at some point. But yeah, so this is how we can do that. So, and taking a sentence and turning it into a bag of words is as simple as applying like 3 functions. Split it into words, map words to bag of words, and just fold all of that into a single one. Does it make sense? Hopefully. Do you know about fold map? Yes, I do know about fold map. It doesn't matter. It's the same thing. Bike shading, by the way. So, what is the number? The amount of words in the sentence. So, how many words do we have in the sentence? And by the way, maintaining the bag of words for the spam and maintaining the bag of words for the ham is super simple. You take your original bag of words, you take a new message, right? You just turn it into a bag of words and you merge it with the one that you keep maintaining. So it just makes it a whole lot easier. Thank you, Mr. Scalder, too. Hello, Ford. Welcome to the stream. Oh, this is not for you. It was for supercuber, but yeah, there we go. There's a special command for that. Okay, so that should be it. And another thing I want to do, I want to be able to take a bag of word and then a word and just get the probability of that word, right? So let me try. Probability, maybe word probability. So it takes a bag of words. Maybe it should first take the word, like this, and return the probability, and we're gonna store the probability as a float, right? Because it's gonna be a value from 0 to 1, right? To be fair, like, it's kind of difficult to distinguish word from just a text. Maybe we need to introduce like a type alias called word, and I think that name is already taken. I think that name is already taken. Yes, there is like data word module, and they have types like, I wish the pages were a little bit smaller so they would load up a little bit faster, but the Haskell developers like huge pages that load for ages. An intentional rhyme, by the way. Yeah, it's just like I cannot do anything because the page is still loading. This is how huge it is. Like, it's enormously like huge. It's just still loading. Yeah. And it's especially slow on my machine because I'm also streaming from that. Okay, thank you very much. All right, so we do have a word, and it's an unsigned integral type. Okay, so that kind of creates a problem. So maybe I'm not going to do that right now. So here's the word, and here's this thing. So what we need to do, we need to take the amount of these words in the bag of words. So we can do that by using lookup function, right? We can do a lookup function. So we're gonna look up this word in the bag of words, but we also need to destructurize it, right? Otherwise we won't be able to do anything. And that returns us maybe. That returns us maybe, and if we cannot find the word in the bag of words, we're gonna assume that the amount of these words is 0. So for that we can have functions from maybe, which is available in the module data maybe, right? And if it, for example, nothing, we should be able to, okay, I will have to recompile it. So from maybe 0, right? That gives us the amount of those words in the bag, right? Something like this. And then what we need to do, we need to define, we need to divide that by the whole amount of words in the bag of words. So how can we know? So words count. Let's implement an operation that takes a bag of words and returns us the whole amount of words. So to do that, we'll need to sum up all of the values of this bag of words. So as far as I know, you can literally just take a map. You can just take a map, turn it into a list, right, like this. Then you can map it. So the when you turn a map into a list, you get a list of pairs, key value, key value, key value. So that means we need to extract the second value and just sum everything up. So that's going to be the thing that counts words. And yeah, we can just do words count for that specific bag of words. But this is an integer and this is an integer as well. So that's not going to work. We need to convert them to floats. As far as I know, the easiest way to do that is just to call from integral. Don't ask me how that works, it just works. From integral, there we go. So that should work, but it doesn't, because oh yeah, because this thing has to be bag of words. God damn, okay. So that means I'll have to do it like that. And then here, I'll need to convert it to map. And now it compiled. Okay, so we have an operation that counts the probabilities. Right, so now let's take our original thing. So here is our bag of words. So here it is. And we can pick some word from it, like lorem, and take a look at its probability, like word probability. This is it. And here's the probability. It's very low, apparently. How about the? Yeah, it actually has a higher probability because there's like at least 3 of them, right? So essentially, how does it calculate probability? It just takes 3 and divides it by the sum of all of these numbers here. It's very simple. It's very straightforward. Right. So now we have a ways to build a bag of words and also count word probabilities, and that should be enough to train things. Actually, that is already enough to train things. The only problem is that we don't have a way to dump bag of words to file system. Maybe we can. Maybe we can just, this thing is showable. We can essentially just implement a read interface for it, and there we go. We have serialization, deserialization. Maybe for now we don't need any special databases or anything like that. We can just use like files or whatnot. Maybe even JSON. Whatever. So now we need some data to train our models. Where can we get that data? Spam data sets. Let's find some spam data sets. Spam ham mail data sets. So maybe if we can find something here. Does anybody know any good, data sets that we could use? I don't know what it is, and I don't know why does it take so much time to load it up. So this is a solution in Python. Excuse me, spoilers. We're not going to use that. I'm not going to use that. Spam ham. Okay, so there's like a 5 megabytes of that. Can we download this thing? Please don't tell me I have to have a account there or something. Okay. Fucking damn it. All right. So you want a spam data set? Oh, you're generating it. Okay. Okay. Email classification spammer ham. This work is a part of mini project. Okay. Email classification. So there's a spam. Oh shit, that's actually cool. So we have something here. Oh shit. Okay, so can we use this thing? And there's also ham. Nice. Absolutely nice. Okay, we're gonna use that, hopefully. What's the license of this thing? There's no license. They didn't provide any license. What the fuck? What the fuck? Well, I mean, it's publicly available. Data says, okay. Oh, okay, so they took it from here. Spam ham messages into the set we use is taken from link here. I don't know what it is, but okay. Here in one. Anyway, I'm gonna just take this one. That's it. Alright, so I'm also gonna create a readme. And we're gonna put it into references. We're gonna put it into references, and that's basically what we used here. Okay, so I'm gonna just clone it. I'm just gonna clone it, and we'll see. It's a bold move. Yeah. I mean, ветчина is a ham in Russian, so, and not only in Russian, probably like in other Slavic languages as well. So email classification test S or H. So how does ham look like, by the way? How does ham look like? So subject. So this is like a farmer. These are really strange emails, but okay. Okay, so we're gonna have something like data, and we're gonna just put it here. Just put it here, and we don't really need much, to be fair, right? We don't really need much. We just need this kind of stuff. So I need a function that would take a folder, right? Take a folder, take all of the files in that folder, and give me the bag of words for each individual file. We can start with, you know, with just a function that takes a single file, right? Bow from file, right? It accepts the file path, and returns a bag of words. So what's interesting is that it performs I/O because reading from a file performs a side effect, right? Because it's essentially interacting with the real world. That's why we have to do it like that. All right. So how can we do that? So, in Haskell, we have a function called readFile, which essentially just reads the whole thing into a string. But we're not using strings, we're using text, which is like a third-party dependency. The problem with strings in Haskell is that they are literally list of characters. So this is how they defined in the standard library of Haskell. They're a list of characters, and list in Haskell is a linked list. I'm not even joking. Haskell, by default, uses linked lists to represent strings. Yes, this is not a joke. It is what it is. And that's why in real-world Haskell application, nobody uses strings, right? Because you're gonna end up with a very low performance. And everyone uses text. It's a third-party dependency which basically implements efficient strings for Haskell. And so text, the thing that we use here, is essentially like a binary contiguous buffer in the memory, right? But it implements all of the string operations, like as usual. Okay. And because of that, we're not going to use readFile, right? Because readFile works with strings, but as far as I know, text module provides I/O replacements. It doesn't. Okay, I just have a compilation error here. So I think it has something like readFile here, if I'm not mistaken. Yeah, there we go. So it's essentially like a classical readFile from the prelude, but it returns the text, right? And this is exactly what we're going to use here. So what we can do here, we can do t readFile and try to read something from our data set. Let's actually try to read some spam. So what kind of spam do we have here? So 006, there we go. And we have our text, right? We have our text, which we can then split into words. You cannot just split that thing into words like that, because readFile doesn't return text, it returns I/O text, because it performs a side effect. So to apply anything to that text, you have to penetrate it with the functor operator, right? So you have to do something like this. You split it by words, then you map each individual word. Well, you can also fold map it, right? You can also fold map it word to bag of words. And that should give you, it didn't really work. Word to bag of words. Oh yeah, this is because I have to compose them. Yeah, there we go. And this is how easily you can just take a file and turn it into a bag of words. Right. Hello, Tim Sanchik. Thank you. Thank you so much. Okay, so this is how we easily can do. But of course, somebody already mentioned that in the chat. We probably want to normalize some of these words somehow, right? Maybe like get rid of the special characters and maybe bring them to the uppercase. By the way, what are the alternative preludes are you guys talking about? I never used them. Is it like Relude or something? And I've never seen anybody use them in like serious Haskell projects. Is that what you're talking about, Relude? Yeah, Relude is good. Okay. Maybe we'll take a look at it at some point, but usually I compensate for like by using the text package instead of strings, and also quite often I use this thing. It's a safe package which introduces like safe versions of head, tail, and stuff like that. Yeah, so usually it's enough for me, but I mean, yeah. Anyway, so this is how you can just take a single file and yeah, essentially turn it into a bag of words, and let's try to implement that. So here's the file path, and there we go. Should be pretty straightforward. Split by words and turn it into that. So maybe we can even have something like this. So we have a word and we can have text to this, to bowl, right? And here's the text, and maybe it can even be like this. Text to bowl. Yeah. So we split it by words and then we fold map it into the bag of words, and now we have that. So now we can easily take any file and just turn it into a bag of words. But we need to have something like bowl from folder, which takes a file path to a folder and basically collects like everything from all of the files, giving us the final bag of words. To do that, we need somehow get the list of the files in the directory. I have no idea how to do that in Haskell, but maybe there is a package for that. I'm pretty sure there's something like a directory package. No, there was no advent of code today. I'm gonna do advent of code at the end of the stream if I'll have enough time and energy. We'll see about that. Okay, so there's this directory thing. Rename list direct. Okay, there we go. That's actually pretty cool. So let me try to. Do I even have that as a part of the installation? GHC package list. Let's do it like that. Direct. Oh, would you look at that? So directory is actually part of the distribution of GHC, so I don't even have to. I don't even use like any like real third-party dependencies. Like everything I use is literally part of the installation of distribution of GHC, which is just kind of nice. Not gonna lie. Hello everyone. Hello Sen12. All right, so I think we'll have to restart because we have updated. Yeah, we have updated the Cabal file, so it will need to like pick up the third-party dependency and stuff like that. All right. So, and if we import system directory, oh there we go, it even picks it up. I should be able to use functions like list directory. That's pretty cool, I'm not gonna lie. And then we're gonna have data, something like spam. And there we go, we got a list of all of the files. That's actually super cool. That's so easy. You just do list directory and get a list of all of these things. And it's a list of file paths, but I mean, it's totally fine here. All right, so that means we can easily implement bow from folder by doing something like this. So this is a file path. Hello, Mihpihnati. Did some of you consider doing one day Haskell with CommonNet? I don't know. I already wasted Haskell on, I think, the second or first problem. So you can check out my Advent of Code repository, and I'm doing a very original challenge where I use a different language for each day. And I already wasted Haskell, I'm sorry. I wasted Haskell on the second day and Rust on the first one. So, and yeah, that's the languages I left with. So I haven't touched 10th or 11th problem yet, so I haven't even read them, so I don't know what they're all about. Okay, so here's the list directory, right? So, and what's the next thing we can do? We'll probably have to do something like this, where we're gonna map m with bow from file. And I guess that's the whole implementation. Is it the whole implementation? No. God damn, why is it not? Because bow from file couldn't... Oh, I see. So you map m them and you get a list of these bows, and after that you have to actually fold them. No. Is there something like fold m? Is there something like fold m in Haskell? So basically fold, but also with monad, like fold lm. Okay, I think it does exist. And how we're gonna actually fold them? If we're gonna folding also should return a thing. Yeah. So I think I'm not gonna try to be fancy, right? Let's not try to be fancy, okay? And let's do something like this: files, right? Then we're gonna have bows. So it basically map m bow from file. Emacs, just autocomplete what I want. Oh my god. And then what we just return is fold bows. There we go. Is it gonna work? It does work. You see? So once you stop trying to be fancy, you actually end up with more readable code. You see, it's so readable. If I try to do like this, you know, binding, fold m, fold map, nobody would be able to read that. But look at that. List directories. Take the files, turn them files into bows, fold them, and there you go. We get the final bow. So yeah, so it's quite difficult to not try to be a smartass in Haskell, because you kind of always want to, because it enables you with all of these quite cool things, but it's better to write it like that. It's just more readable generally. Okay, so and that means we should be able to do the following thing. Spam bow, which is going to be bow from folder. And where is the folder located? It's located in, oh my god, Emacs. What the hell is wrong with you? Spam. It's basically Emacs is trying to be helpful, by the way. Yeah, thank you very much, Emacs. Very cool. Okay, and here's the ham. So now, automatically, if I try to access this thing, I can do words count, and it didn't. Oh yeah, this is because it's exception. Open file does not exist. Oh shit. Okay. So these are the just regular files. These are just regular files. So there are not full file names. So let me call it like that. This is going to be folder path. This is going to be file names. And the next thing you have to do, actually, you have to take a single file name and take a folder path, and merge it with the file name, like this. And I think that will work. Okay, so you can count how many words in a spam you have, and you can count how many words in a ham you have. There we go. So that's how many of them you have. Yeah, so essentially we already build both of the models. And what's funny is that we read them from, like, we build them every time we run this thing. Yeah, so we have both of the bags of words for spam and not spam. Okay, but I wish I could do something about that. Can we simplify it like this? I said that I'm trying not to be fan. Oh, yeah, there we go. I actually simplified it. Look at that. Is that even readable? Can anyone decipher what the heck is that? Well, I mean, if you have experience with Haskell, you probably can, but I mean... So this is a partial application of binary operation. We partially applied the first argument, right? And we compose it with a function bow from 5. It's actually equivalent to this, right? So essentially I perform eta reduction, partially apply this thing, and I just compose these two functions together. Yeah. So kind of cool. Anyway, so we have both of the bags of words, and now I think we're ready to do some classification. You know, it would be kind of cool to actually train on half of the data. You know, in a real machine learning, how people do all of that. They take their data, their training data, and they split it in half. Like half of the data is used for actual training, and another half is used for control. Like it's sort of like, I don't know the exact terminology, I think it's some sort of control data. So, and that control data is the data that the model never seen before, right? And it's used to check how well the model performs. I think we need to do something like that, boys and girls. I think we need to do something like that. Let me see. So now, I think I want to commit everything we have here. So it's already available. So git ignore. What kind of stuff I want to ignore? I definitely want to ignore this new style. And in a readme, so I have references. By the way, speaking of references, I also need to add the article that I used here. Test set, validation set. Thank you so much. I'm not like a machine learning, artificial intelligence person. I literally know nothing about all of that, so I may actually butcher the terminology quite a lot. So thank you so much for correcting me. Where you're here. Anyway, so quick start. I don't know. Do we need any quick start right now? We have nothing working, so I don't think we need any quick start. So, and also I'm gonna put the license. So what's gonna be the license? I'm gonna use MIT license. We will teach you. Sure. All right. Okay. And the year is gonna be 2020. The copyright holder is me. So, and this is gonna be the first commit. Oh, I don't even have anything initialized here. Git init, and let's take a look. So, I'm gonna also commit data. I put the source, yeah, I put them in the reference, so hopefully that will be okay. Ready, set, go, and let's create a separate repo. I can stop stroking my head. All right. So yeah, what's gonna be the description? What's gonna be the description? I don't know, to be fair. I'm gonna actually come up with this description a little bit later. Hello Droka, welcome to the stream. Hello, hello. Haven't seen you in a while, I think. I'm not sure. So let's add the remote. The remote has been successfully added, and I'm gonna push that right into the repo. So get ready, boys and girls. Get ready. And yeah, there we go. So it should be available here. So Vetchina. It's supposed to be pronounced like that, not Vetchina. To be fair, maybe I should actually rename it to like, since it's supposed to be pronounced like that, maybe instead of I, I'm gonna use double E to like emphasize that that's the Russian pronunciation of that word, and to avoid controversy as well. Yes, I think that's gonna be the thing. To be fair, it just makes the word too long. It looks nice. Thank you, Droka. Pig. All right, maybe that's what I'm gonna do. How do I rename that? I think it's gonna be in the settings, but this will require a lot of things to rename, so we have to rename Cabal. Yeah. Okay, I'm renaming it. You know what's cool about GitHub is that if you rename the repo, the old name will redirect back to the new one. You see, it automatically redirected it. Okay, so let me try to first of all rename the folder. Yeah, and let's find all of the files. Yeah, there's only one file, so it's gonna be called like this. And all the things here. Okay. There was not that many. Okay. So, and one of the things we'll probably have to do, we'll have to remove that stuff, and I'll probably have to restart Emacs just in case. Oh, by the way. Hello Tolga87, welcome to the stream. Welcome. Also, check out the whole FAQ as well. I mean, it points at the whole FAQ. Alright, so I'm gonna try to open this thing and see what's gonna happen. Hopefully it will work. Alright, so now I think I'm ready to add this thing. Edit Lambda functions to Excel, it's Turing complete now. Maybe something for the next advent of code. I don't have Excel, to be fair. But I mean, I think maybe I can use like a web version of Excel or something like that. I don't know. So, what's the project? That's CMD project. Today we're implementing spam filter in Haskell. Source code. There we go. Cool. Is the word too intimidating for people who don't speak Russian? I don't think it's too intimidating because, like, you can kind of split it into vet, and then China is not that weird of a word, I think. I don't know. Word is fine, okay. Because Russian language has, like, weird long words sometimes. As a non-Russian speaker, no. Okay. Thank you so much. All right. I need to commit whatever changes I already made. Yeah. All right. Cool. Debian was the OS we used in the college too. I mean, yeah. I think the university here, Novosibirsk State University, used to mirror both Debian and Ubuntu repos at some point. They stopped doing that for some reason, I don't know why, but that was kind of interesting. if you lived in Novosibirsk and you use Debian, for example, you could point all of your repos to the NSU repos, and you're literally going to be physically as close to the repos as possible. You're going to be not only in the same city with the mirror, you're going to be in the same district with the mirror if you live like where I live. And it will be super fast, especially if you want to update something. It's super cool. Nice haircut. Thank you, Figli. I hope I'm pronouncing that correctly. It's not called your country with such a hairstyle. I mean, I have a hat. It's like, and it's not about the country. Like, in country is actually pretty huge. Like in different places in the country, it's like has a different, you know, temperatures and stuff like that. So, there was a Solaris lab that no one used. They eventually closed it down. Huh. Interesting. Anyways, I think we're ready to split our sets into the training set and validation set. So I think I'm gonna do that manually. So we have ham, spam, and is there like a super easy way for me to do that? I wonder. I can't get out without a hat in the cold. It gives me terrible headaches. Well, yeah, understandable. Wait, there's hair. Okay. Let's continue. We have some stuff to do. All right. So what I want to do, I'm gonna do list directory, and I'm gonna go into the data ham. Right. So here, this thing. Oh, here it is. I wonder if I can now calculate the length of that list. And see, okay, so this is like 100, so 100 messages. And for the spam, we have also 100 messages. So maybe we can simply take first 50. Maybe the training set has to be actually a little bit bigger, like maybe, let's say 80, and 20 messages we're going to use just for validation. And we have to move them to a separate folder. That's what we need to do. This sounds like machine learning. Well, I mean, that's pretty much what machine learning is, isn't it? I don't know. I'm pretty sure there is no like a exact definition of machine learning or anything like that. So how am I going to split all of that? So maybe we're going to have data, then we're going to have train, and I'm going to move both of these folders here, and then we're going to have validate, and in the validate, I'm going to have also these two folders. It's going to be ham, and it's going to be spam. Cool. Okay, so in ham, I wonder if I can do something like this. Then I'm gonna go down 49 times. And can I mark all of them? Apparently I can. Huh, that's very convenient. So essentially I can mark everything. Right, so this is a 49. And this is gonna be 50, and I'm gonna move all of them to here. That was easy. Oh shit. Emacs is the best file manager because I can just say, like, move first 50 files to this folder, and it just did that for me. Can your Vim do that? I think Vim can do that because Vim also has like this file manager, and you can also say like move from that like 50 times down, and also select everything, and maybe select all of the files and move something. I don't know, but that's literally what I did. So you used Emacs like one OS. What is one OS? Anyway, so both of these things are ham. Okay, so this is the train. Okay, we're gonna go to the spam. Benny Darshan.
You are the income also you had to subscribe.
Do I? Am I really doing machine learning? Because I don't know. I know nothing about machine learning. I just heard this cool technique and I just wanted to try it out. But thank you so much for 6 months of tier 1 subscription. Thank you, and welcome to our epic machine learning club. Apparently, I don't know if it is. So this is a spam, and as far as I can tell, this is okay. 100. This is 50, and let's go to spam. All right. I'm gonna go 50 times down, and that is actually too much. All right. I want to double check that everything's okay. So this is a spam train. Says this is the spam validate, and there we go. We moved everything. Cool. So I split our set into training set and validation set. Nice. Let me see what we've done. Yeah, that's cool. Now here we'll have to redirect them. So these are training sets. So this has to be trained, and this is also has to be trained. Otherwise, it's not going to work. So I need to update everything here, and state changes also update all of that. Machine learning is when you have a system where you don't write specific rules for decision. The system decides based on the past data. I guess it's one of the definitions of machine learning, I suppose. I suppose you can call it like that. So let me take a look at the at my bags. So this is going to be a spam bag. Okay. So I think it contains less than it contained before. Yeah, it's supposed to actually contain less because we have less data. Oh, goddamn. I wanted to split them. Not 50-50. I wanted to give more data to the training set and less data to validation set. But I mean, we can change that later. Whatever. I'm gonna fix that later. Split set into training and validation sets. Split. What is split? Split sets into training and validation sets, and I'm gonna push that right into the repo. You can find the source code of whatever the thing we're developing here. Okay, so I think the moment of truth has come. The moment of truth has come. We need to implement a function that takes a word and give us the probability of that word being a spam or being ham. Actually being a spam specifically, right? So we need to implement this formula. Are you guys ready? Are you guys ready? Let's go. Can you do tutorial, please? Okay. So how are we gonna call the function? Word probability spam. So we already have a word probability, so we need to introduce word probability spam. So in this thing, word probability spam is gonna accept a text. It's not gonna accept any bag of words. It's gonna use both spam a bag of word and ham bag of word, and it will return us the probability like in float from 0 to 1. Okay, and so first we need to take the probability of the word if it is spam. So we can even call them like this. So PWS, right? So PWS, Lindra Braga.
Thank you for the great streams.
And thank you so much for 2 months of Twitch Prime subscription. Thank you, and welcome to our machine learning club. Yeah, I hope it's interesting. I actually having a blast. I really enjoy what I'm doing right now. Maybe that's why a lot of people like doing machine learning, because you just implement this magical model and it magically works and makes you feel like you're doing something important and something cool. I guess, because that's what I feel right now. Right, because I couldn't come up with these formulas myself, obviously, but I just implement them and it feels cool. Nailed it? Okay, that's the reason why people like it. Okay, I see. I can see the appeal. Right. So, yeah, so PWS and PWH. So the formula is PWS plus PWS plus PHS, right? And now we have to implement that. So PWS is equal word probability. It's actually a word probability, just word probability. And that specific function takes a word and a bag of words. In that case, it's going to be spam. So you see, it's a probability for it being a spam. And similarly, PHS is a word probability for ham bag of words. There we go. And I think that should be it. Why is this so simple? Okay, so I think that's literally it. So we have all the statistics, we just use the statistics, and but this is only for a single word. This is only for a single word. Okay, so oh goddamn! So here's the problem. These things. Yeah, these things, they produce side effects because they had to be read at runtime, so we have to do it like that, unfortunately. Yeah, it will return this. Well, it is what it is, and it isn't what it isn't, so... okay. So we could try to read these files at compile time using template Haskell. That would be cool. Imagine like this code executing at compile time and just returning like a bowl. Huh. That would be interesting. Template Haskell is pure evil. Well, I mean, it's kind of cool. Like, it's literally like macros, but it's not just macros. They enable you with executing like arbitrary code at compile time. And that is cool. I'm not gonna lie. But I'm not sure if I know enough template Haskell to pull that off. Okay, so we're gonna move this stuff here. Maybe at some point I'm gonna, you know, make it compile down. So if I'm gonna use template Haskell, I will essentially bake the data into the executable, which will help me to get rid of I/O. But I mean, I'm not sure how useful it will be. Okay. So here's that, and one of the things I'll have to do, I'll have to penetrate all of this, and then return all of this, and there we go. I think this is how we can do that, and it compiles. Okay, so I just restructured my code, and that's what it is. It will always produce side effects and stuff, even though it shouldn't. Yeah, because this thing should just accept two bag of words, right? So, to be fair, if you think about it, it just should accept two bag of words, but whatever. Word probability spam. Okay, so we implemented. So if the message contains word hello, what's the probability of that message being a spam? Okay, that's very interesting. What about world 1 test 0? Yeah, huh? This thing is 0, none. Oh, it's in case, yeah, when both of them are 0. Yeah, what if both of them are 0? Okay, this is very interesting. Yeah, when both of them are 0, you basically have division by 0. Hello, I'm a spammer. So, and Haskell also will give us none. So basically, it's a word that we've never seen before. Food, hat. Okay, I'm a engineer myself, and the company I work on moved from hiring statisticians to software engineers. That's because in the end, in production, the most difficult problem are the ones that software engineers already know how to solve. Cloud infrastructure monitoring, version deploying. The machine learning part is not that difficult to grasp for a programmer. Yeah, this is something that I heard about. Right, it's just more important to have the software engineering skills than math skills, because, yeah, a specific math for a developer, for a software engineer, is not that difficult to grasp, because they have to work with several branches of math simultaneously anyway, so programmers kind of usually used to math anyway. Haskell is back to sorting stream. I mean, it was never gone from sorting streams. It was just, you know, I just stopped developing the bot on the streams. So, but I program in Haskell on this channel from time to time, so it's totally fine. Okay, so I suppose if both of the words return 0, right? If both of them return 0, what should we do? The probability of it is essentially 0, right? But if it's 0, and oh yeah, and we also, the final is going to be that. So I'm just thinking how to handle that. We can simply try to do something like this. So we're going to have p sum. So this is a p sum. And we can just have something like this. If, maybe even return. If both of them are literally 0, Nuffly, what's up Nuffly, hello. I know that it's very bad to compare floats with equals, I know that, thank you very much. But I think in that case it's gonna be okay. Because if the word doesn't exist, we're literally assigning 0 here, and it's a very specific value, and like in IEEE 754 representation, and summing up to zeros will end up with 0, and I think in this particular case it's totally fine. So yeah, so I think it's totally fine. But I do know that you're not supposed to compare flows like that. I do know, like I've been in, you know, in university, I studied, like I know. Okay, so what do we have here? Oh, this one is, yeah, this has to be 0. Okay. It would be interesting 1 or 2 streaming dedicated to Emacs OS. What is Emacs OS? I don't know what you're talking about. Okay, so this is 0, this is hello, this is hi. Test. Lindra Braga is gifting tier 1 sub to Toding community. Thank you so much for supporting the channel. And TNK Han, welcome to our epic machine learning club. Will you be solving Advent of Code today? I don't know yet. I need to finish this thing, and we'll see about that. So I'm not sure if I'm doing this correctly, and all of the machine learning engineers probably already left, so nobody's gonna help me. But we'll see about that. So let me double check. So this is only for a single word, right? This is only for a single word. Probability of that word if it's a spam. Probability of that word if it's a ham, and so on and so forth. Okay, so, but this is only for a single word, right? This is only for a single word. The next thing we need to do, we need to do that for a sentence, right? For the whole sentence. What's funny? Is it really gonna be like less than 1? Is it really gonna be less than 1? It's 0. Okay. All right. So let me see. So let's do that for a sentence as well. Let's do that for a sentence. Sentence probability spam. So we're gonna take this thing I'm gonna take this, oh my god, and we're gonna return float. And the next thing, we need to take the sentence, maybe just text. Let's call it text. Right? Let's just call it text. And split that text by words. Split that text by words. Then here are the words. After that, we need to map all of that to the probabilities. So we're going to do map m word probability spam. So that gives us the probabilities. Now we need to inverse those probabilities, right? We need to inverse them, you know, like this. So to inverse those probabilities, we're gonna do map ps p minus p. There we go. And there we go. After that, we need to multiply all of the probabilities. I think we have a special function for that. Product. So I think we do have a special function for that. Product, yes. If it's gonna be too long, I don't know. Divided by... Yeah, so product of probabilities, I'm gonna call it PP. Right, product PS. So we take PP divided by PP plus product of inversed IPs. And we will return all of that, like this. So text probability spam. Text probability spam. And I feel like I definitely did something wrong here, because like word probability is really scuffed. It is really scuffed. Okay. So we can take a text probability now. Should it be... Yeah, it should be plus in denominator. Thank you so much. Thank you. So already do it like this. Word probability, text probability is gonna be hello world, and it's 100% spam, and it's none. Okay. So I'm definitely handling non-existing words incorrectly. Return PP. Made a good progress on my probability theory homework, so now I can get back to watching this probability theory stream. Alright, so we're already starting to have problems, like specifically here, I think. Because I think word probability works really strange. So if it's a test, it's 0, hello, it's that, and it's never really anything in between. Like, it's really strange. So if I try to check that word in a spam thingy, so like this is the probability. This is the actual probability in a spam. So if think a spam, this is the probability of having these words, but if it's a ham, it's 0, and hello is also 0, because we never have hello there. But maybe this is because I never really properly normalized the words. That's probably the thing. Yeah. So yeah, so I think I just never properly normalized the word. Let's try to normalize them. Yeah. So we need to have some sort of function, sentence, like text, maybe normalize text to words. So, and it's gonna accept the text, and it will return you normalized words. And I think we already did something like that before, right? I think we already did something like that before. I need something with punctuation marks. So something we do have, whatever that is. Yeah. So essentially, I want to first remove all of these things that are not alphanumeric. I know that it's kind of dumb, but this is an educational project, okay? So this is going to be a text map, and if I will need to import data char. So we'll need data char here, that's for sure, because how else can I classify characters? Incorrect indentation. Okay, so if is alpha num, then I return this thing, otherwise I replace it with space, like this. So this is the first thing we're gonna do. We get rid of all of these things and then we split them by words. Right, they split them by words, and then we map all of these words with two upper, and there you go, we normalized all of that. So I know that for the spam filter, getting rid of the special characters is not particularly great idea. But for educational reasons now, I'm gonna do it like that. So this is the way we're gonna normalize the text, right? So this is the whole function, and I'm gonna just put it here. I'm just gonna put it here, and I'm gonna replace it like this. There we go. Maybe I can simplify it. I don't think I can easily simplify it. So yeah, so normalize text to words. Okay, so and every time we are trying to do like words. Yeah, so text to bowl, instead of just using words, we'll have to use normalize text to words. Do we have any other situation where we use words? No. Text probability spam. Normalize text to words. Okay, cool. So yeah, so we did normalization, so now the bags should be slightly different. So if I take the spam bag, it will contain less words than before, because we probably removed a majority of them. Yeah, it actually contains less of them. And ham, how many contain? Yeah, ham doesn't contain that much. We can take a look at them, because why not? Oh, that's a lot of them. Yeah, so as you can see, all of them are normalized now. Oh my god, it's actually super slow. Let me restart this entire thing. Okay. So, maybe now it will do something. So text, probability, spam, and I'm gonna do hello. And the probability is still this, world test, 0, 0, still doesn't work. So normalization didn't really help that much. To be fair, I wanna have some sort of a tool. User was banned for this post. I don't understand what you mean, I'm sorry. Okay, so print summary bowl. I'm gonna take a bowl and I'm gonna make it perform a side effect. So I'm also gonna destructurize it like this, and I'm gonna do to list, and then I'm gonna try to iterate all of this. So for m. Oh, you mean hello? I'm sorry, my brain is completely in a different place right now. Okay, so in here we're gonna have a word, like a word itself, and its frequency. So it's gonna be f, and I'm gonna do it like that. I'm gonna print f. So I'm gonna print that word and its frequency as well. So I just want to see how it's gonna go here. And to have printf is gonna be text printf. There we go. Is it gonna work? Is it gonna compile? It doesn't compile because I have to import something like control monad, I think. Because without control monad, it's not really gonna work. And even without that, so like I remember that Haskell has a really strange quirk that for m is available in control monad, but for m underscore is located in like completely different place for some reason, just because. Data foldable, so it accepts the list. Yeah, it's it has to be like this. I didn't look at the error. Okay, so now it works. Now it works. Okay, so now I can do something like summary. No, it's not here yet. We have to put it like that. Summary bow, and then we're gonna have spam bow. And since this is the side effector thing, we'll have to do it like that. Printf bad formatting. Sure. Please print it now. Okay, so that gives us that. Huh. Cool. So this is the words for spam, and they're very different. They're very different, to be fair. Okay, what about ham bowl? For the ham, U is actually very... So can we sort them, by the way? Can we sort them by the second value in a descending order? That will be actually kind of cool. So M to list, sort by... sort by. We don't have sort by because we have to import lists. Okay. Import data list. There we go. Sort by. So it accepts the ordering and the list itself. Cool. So the ordering is a function that, yeah, I think you can construct it like this. If you have import data function, you can create a comparator, compare on second, and that will actually sort it appropriately. Yeah, I think it works. So now if I take spam, yeah, so the most used word, it didn't even sort it properly. What the fuck? Wait, am I crazy? Yeah, I'm crazy. Okay. So yeah, so the least used words and the most used words. And for example, word probability. I want to take a look at the word probability of the, actually the, in the spam bowl. And it's very low. Why is this so low? Hello, PNQ. So maybe my way of computing probability is actually not particularly correct. I don't think it's particularly correct. Right. So, because the probability of that word should be actually huge, is it not? I think like, because, yeah, probably because the sum of all of these numbers is too huge, so there doesn't really appear that probable, but it does make sense. Maybe we just need more data. Yeah, it feels like we just don't have enough data maybe for it to properly kick in. So when we sum up all of the words count, right? So we take the list, right? We convert it to the list. We take the second. The number is low, but the value is the highest for words in that bag. And yeah, the number it is. Okay, so and then we sum it up. Okay, so I don't see anything wrong here. I didn't see anything wrong here. I didn't see anything wrong anywhere. So the thing that actually concerns me, this is supposed to add up. Well, it isn't. Is this sum down below supposed to add up to 1? I don't think so. Probability of this word, if it is a spam probability, it can be, yeah, it can be anything, but since you divide it by that value, no, it shouldn't be, it shouldn't add up to 1. Okay, so that means I'm doing everything correctly. A naive Bayes, yes, it is naive Bayes. That would make it useless. Yeah, I realized that. Because it would be equal to, like, yeah, it's kind of useless. Alright, so that means I didn't make a mistake there either. So that means I may be handling incorrectly the words that we never seen before. Maybe I handled incorrect. Hello, hertz and plots? Yeah. So, for example, if the word is used that we've never seen before, neither in spam nor ham, what should we do with that word? Right now, I assign a probability 0, which is probably incorrect. So probability 0 of being it spam and probability 0 being it ham, which is like a kind of stupid. What if we just throw away all of the words that we've never seen before? How about that? In both ham and spam, right? We just ignore them. I think that would be actually kind of good thing to do. So that's yeah, let's just throw them away. Yeah, it looks because I think they ruin the whole statistics. If we take the words that we've never seen neither in spam nor ham before, and we assign probability 0 to both them being spam and ham, it ruins kind of everything. So I think this shouldn't be taken into account at all. You don't have enough information anyway about this word. Yeah. But if we have that word in spam but don't have it in ham, I think we still need to take it into account, because we've seen that word, we know that it's used in spam, and we know that it's usually not used in ham, like at all. We've never seen it used in ham. That's a useful information. If neither of them contain this word, we don't have any information at all, throw that away. Okay, thank you. That actually makes sense. All right, right. So, seen before. By the way, I'm just thinking, I need to make sure that we always normalize the words correctly. Word probability. So, for example, here we not necessarily may normalize it correctly. I kind of want to introduce like a completely new type that is called word. But unfortunately, we already have a word located in module data word, and I don't think we're gonna use that module in this particular like example. So I think I'm gonna take it here. Word, and it's gonna contain just simply a text, right? It's gonna contain simply a text, and you shouldn't really touch the internals of this word. The only thing you can do is construct a word from text, like a single word from text that accepts the text and returns you a word. And the thing we're gonna do, we're gonna always try to normalize it, essentially. So if you have a text, and then we're gonna do to upper. So, and everywhere we accept the word, we have to use this type. So it will force us to always normalize it. Text to word. Maybe I'm gonna call it make word. Hello, Cozy Whiteware, welcome to the stream. Yeah, make word. So normalize text to words. So that means essentially when we have a bag of words, instead of like text here, we'll have to use word here. There we go. And that will force us always to convert and normalize properly. We also need to do something like derive and show so we can see everything properly. And I'm gonna go through all the compilation errors just to see. Okay, so we have a word. Biggest occurrence prelude. God damn it! Prelude imports word. Oh my god! Why do it's such a useful word? Okay, let's give it a different name then. What could we call it? We could call it like a token. Is that a better name? Well, maybe we can exclude it. Yeah. So maybe we can exclude it. That's also a good idea. Thank you so much. Prelude, hiding. Is it not gonna like hide everything? Term. Yeah, let's call it term. I don't really want to mess with the standard library because it's usually a huge pain in the ass. So let's not mess with it. Let's use term. Okay. So and again here we'll have to use term. Of course, we have to use the term. And this thing also has to be readable. Even though we never save it anywhere, right, I still want to keep it readable just in case. No instance or RD. Okay, that should be pretty straightforward. I'm pretty sure I should be able to do something like this. No instance equal, okay. Do we need anything else? Okay, cool. So word to bag of words. So that means we'll have to do something like this. We have to accept the word. And it still doesn't work. Oh, term. I completely forgot. Oh my god. 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 So that messes up with my brain because I already got used to calling them words. Oh shit. That messes up with my brain. This is actually dangerous. But yeah. Term to bow. Text. And normalize text to words. Okay. So let's call it text to terms. So we get just original text, then we do word, right? We split it by words, we skip everything, split by words, and map it with make word, and that will normalize them. Term to bag of words. Oh god damn it. Naming. Why do I waste so much time on stupid fucking naming in oh my god. It's so infuriating. Haskell, why did you put word into the standard library? Like, why the fuck? It ruins everything. Oh my god. I'm so mad. Like, seriously. And I'm not even because something doesn't work. Like, everything works perfectly. I just don't have enough available names to describe what I want to describe. And it's so fucking annoying. Oh my god. Jesus Christ. Like, just let me use the names. Alright, I think I need to make a small break. Seriously, like, I never thought that I'm gonna be so frustrated by such a stupid thing as how to name a fucking structure. Okay, let's make a small break. So dumb. I think this is because I'm a little bit tired because I've been like programming like 2 hours non-stop. Okay. Alright, let's make a small break and you guys have fun. Yo, what's up? Welcome back. How everyone's doing? Let's continue doing machine learning. How about that? Well, I mean, it was a cutting-edge technology 20 years ago. Anyways, so the problem is that I'm an idiot. That's the main problem, and I'm not sure if like hiding word will help. Can I call this thing word prime? Is that a thing I can do? Just call it word prime. I think I can. I think that's the thing I can do. Yep. Because in my brain I already build a mental model, and in that mental model it is already called word, and there's nothing I can do about that. Like, nope, there's nothing I can do about that. So word prime, I just need to use word, otherwise I won't be able to work on my code base. It's just too late. It's simply too late, and we're supposed to return word prime. So in here I can just do is make word. Okay, is it gonna work now? Bow to map. Alright. So here we have to accept word. There we go. Do we have anything else? This is also word. And the only way you can create a word is by using a function that also automatically normalizes it. Print word, because it's not printable. Well, okay, I think in that particular case we can try to unwrap it, but we should never actually wrap it. Yeah, we should never wrap it. You know what, let's implement a function word to text, or maybe, no, I think it would be okay. So word text is going to be essentially word and returns the text. Word prime, of course. Okay, and in here we can do word to text. So I'm essentially exploiting the type system to help me to check that I always normalize the words when I'm working with them, right? So since like word is a completely separate type, and the only way you can construct a word is by calling this function, and that function always normalizes it, calling to upper, right? Or if you have a text, you always have to call this function, normalize text to words. Yeah. So, yeah. Okay. What do we have here? So I can try to check the, but this is not how it works anymore. You have to use make word. Make word like this, and that's the probability, and it doesn't matter how exactly you spell it, it always normalizes it and stuff like that. Cool. So let me see what we've done so far. Do we have anything to commit right now? I think we have something to commit right now. Yeah. First implementation of the classifier. I'm gonna push that right into the repo. It's probably very buggy. You can always do word some text. Well, you can, but I'm doing that for myself. Yes, it should be in separate module in a hidden, but I'm doing that for myself. Actually, spilled water yet again. Right. So in that case, it doesn't matter. All right. I just applied this policy that for that specific type, I only construct it through this function. So, and that helps me, not anyone else, me, to not make a mistake in the future. Right. All right. Maybe later, I'm gonna maybe separate the module, but right now, since the code is not finished yet, it doesn't work. It doesn't matter. So it's just a small helper. Now, Okay, so we need to implement a function that checks whether we've seen that word before, right? So how are we gonna call it? Sin word. We're gonna accept the word prime, and it's gonna return boolean. Is the code ever finished? Yes. So what do we do? We look up lookup that word in the spam bowl, and that gives us a boolean, not boolean, maybe s maybe ham maybe, and this is going to be a ham. So, and if this is true, if is just SM or is just HM. Cool. So that's exactly what we have here. Is it gonna compile? It's not gonna compile because why? Show me the error. Yeah, because we have to convert all of that. So it has to be something like bool to map, and it works. Cool. So we can check the following thing. Sin word. So, and we have to do make word test. We've seen that word before. Have we seen that word before? Have we seen that word before? We never seen that word before. Cool. So now we can easily check all of that. I don't really like how I made two like global bag of words, and I make functions that depend on this global bag of words, and that forces all of these functions to be side effectish. It kind of ruins everything. So maybe what I'm gonna do, I'm gonna try to refactor all of that and make all of these functions accept this bag of words instead of depending on the global ones. Hello Lazy Grid, welcome to the stream. Welcome. Yeah, check out the hair comment. I'm really sorry if that upsets you, but it is what it is, and it isn't what it isn't. It's just too much effort for me, and I just don't have time for that. I'm sorry. I'm a very lazy person. Okay. I wish I had enough time to actually take care of my look, but I just don't. Okay, so let's do a little bit of refactoring. As a matter of fact, I want to introduce something like a data structure called spam classifier. Right. And it's too long, actually. Can we have something like shorter? Looks like a bold man for brothers. Doesn't sound like something bad, to be fair. I don't know. I mean, sounds pretty good. Alright, so I need a name for this thing, and this thing will contain a spam bowl, bag of words, I mean, and a ham bowl. Actually, I would look like a testicle if I went bald. Interesting. Yeah, surprisingly, the shape of my head is actually okay for being bald, I suppose. Maybe. I don't know. Oh my god. Cool. It looks 5-head. Nice. So, spam classifier. So I wish we had like a smaller name. Spam. Oh my god, Emacs, please. Spam filter. Could be spam filter. Why not? And then we can have something like spam filter. which depends on these things, right? So now he feels every blow of the wind. Is army mandatory in Russia? Yes. Okay. Spam. So this is what we'll have to do, like this, and ham. Then we can remove all of this, and then we can return spam filter spam and ham. There we go. So, and now we don't really have to do any of this stuff. We can just essentially accept the spam filter and word, yeah, and get rid of this IO completely. So spam filter, spam bowl, ham bowl. I have a scar on the back of my head, so going bald isn't the best option for me. Oh, I see. But maybe it will make you look even more brutal. I don't know. Pure spam filter. Yeah, it is going to be pure spam filter. Alright, so, and this is what we're going to have here. So it's going to be a let. Finally, it's going to be pure. You should get airbender tattoos. I'm not a big fan of tattoos or piercing or any like body modification, to be fair. So I'm probably not gonna do that for me. Sorry. Now, might look better, but it depends on the scar and how the person themselves usually feel comfortable or not comfortable showing that scar. Yeah. What are you creating? I'm creating a spam filter in Haskell using naive base classifier. That's what I'm using. All right. So here's the bow, and that means we'll have to do bow 2. Jiang, hello. Welcome. Well, yeah, maybe painting like arrow would be okay. Just temporarily. Bow to map. So I will already do that here. And then I just look it up. Come on. Just look it up, and this is what I have to return. So look at that pure code. The purest of the code. This is as pure Jesus fucking Christ. Okay, I've got a message. You've got mail. I'm pretty sure it's a spam. I can use a spam classifier to detect whether this is a spam or not. Yes, it is spam. Everything's okay. Look at that pure code. Look at that. Isn't that beautiful? I think it's goddamn beautiful. Okay, so we also need to do similar thing here. So spam filter. Oh, you know, I think I came up with a good name for the spam filter. Spam model. Spam filter, spam model. It's a little bit shorter and it actually makes sense. Cool. And this entire thing also should be called like this, something like this. Spam model. There we go. Oh, and by the way, since we're gonna apply all of these functions, yeah, I think we'll have to swap the arguments. Yeah, because I'm gonna partially apply this stuff all the time. Yeah, since it's gonna be partially applied all the time, it makes sense to actually do it like that. Alright, so, and here, we're gonna accept the word. And here's the word probability. So the probability of that word being spam, that's what it is. So then we have a spam model, spam bowl. Oh shit, by the way, we might as well actually do the following thing. Look, we can destructurize it even further destructurization, and which enables us with, oh my god, Emacs, please Emacs, thank you very much. Okay, this is what I was talking about. Okay. Which country in Europe would you choose to move at if you had to move? I'm actually having second thoughts on moving, to be fair. I don't know. Nuligor, thank you. Thank you so much for...
Looking good.
Thank you. Thank you so much for 9 months and for kind words. Tier 1 subscription, 9 months, that's epic. Thank you, thank you, thank you. And welcome to our amazing, legendary machine learning club. We're doing spam filter in Haskell. So it's pretty cool. I'm surprised that the probability is per word. I'd imagine the entire message would be flagged based on the entire content. I mean, it is based on the entire content. We have a separate function that calculates a probability for the single word. Then we go through all of the words and we multiply their probabilities according to the formula. And this is how we get the probability of the whole message. So, yeah, that's how it works, as far as I can understand. Alrighty. And here is an interesting thing. So we should return float, but we should return maybe float. Because if we never seen that word before, we cannot tell its probability being spam at all. But jokes aside, I'm from a country where people made big fake scars because one single bit. That sounds scary. Okay. Very interesting. KGB is coming. They're coming for me. Alright. So, yeah, how are we gonna do that? So we have a particular word, right? And we can check whether we've seen that word before or not. That's how we're gonna do that. Seen word W. If we seen that word, we're gonna do this stuff. If we never seen that word before, otherwise, I'm gonna just return nothing. There we go. And then when we use this entire function, when we're mapping everything, I'm gonna take that into account and remove the word's probability of spam, for which we just simply don't know. Alright, so word probability of this being a spam. Okay, so this is where I can use where. I'm still waiting for Rambo. Ha 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 ha. Cup of pride. And by fake, I didn't mean painted or something, just not natural. Oh shit, that's very brutal. Okay, cool. So, and since all of that is pure, we don't need any of this stuff. Yeah, Haskell definitely encourages you to write more pure code. Impure code is just pain in the ass to write, and that's reasonable, I suppose. That's really reasonable, and because we have seen that word, I think that value should never become none. I'm pretty sure about that, right? So you can just make it like this. And yeah, we should remove equals here. That compiles. Oh yeah, this one has to be aware. Otherwise, oh yeah, if we're gonna return something here, it has to be just get it. And what do you want from me? Is this because of a single space? What do you want from me? Parse input. Oh my god. Seriously, like Emacs, I mean Haskell gets sometimes so annoying. Alright, so is this not because of it's equal? I don't remember. Okay, how do I do condition guards? How do I do condition guards in Haskell? Condition guards. There's something. Did I forget something? It's like you forget like one space and it gets so annoying. Like, yeah, get me to the good part. All right, so it is equal. It is in fact equal. I have a where here. Do I have to add more spaces here? What do I do? Dude, this is so frustrating. Oh my god. Like, is that what you want? Like, the syntax of Haskell just makes me sad. Like, what do you want? And it cannot even auto-format anything. Like, finally it works. It magically fucking worked. Like, oh my god, it's so... I hate it. Ooh. Okay. Alright, and here is spam model. Yeah, seriously, like, it's dumb. It's really, really dumb sometimes. Like, I cannot even describe how dumb this is. Okay. There we go. Okay, finally. Like, I wasn't even fighting with the semantic of the language. I was fighting literally with the syntax. Jesus. Okay. Next one. Spam model. So here we have a spam model, and we have a spam bow. To be fair, I don't think we need anything like that. We can do SM. So we have a text. We normalize that text to a words, which does make sense. Yep. What is at? Okay, so that's a good question. I forgot how this feature is called. Right. So essentially, I'm gonna assume that you know what is a pattern matching, right? So in a function that accepts, for example, like a pair, right? Pair of integer, and returns something something else here. You can perform different pattern matching. For example, you can throw away the first argument and only pattern match by the second one, and there you go, you can have a second one. But you lose the access to the whole structure. Once you destructurize it, you don't have the structure. But what if you still want to refer to this pair as a single argument? Right. In that case, you can just use as pattern, right? Yeah, as Yang said, as pattern. So, and in that case, A is going to be equal to the second element of this pair, and X is going to be equal to the whole pair, including the first one and the second one. Make sense? So essentially, you're destructurizing without losing the structure. And here's exactly what I'm doing here. I'm extracting the bag of words, but I still can refer to the whole structure because then later I'll have to pass it to scene word, right? So that's basically what it does. That's basically what it does. Hello, Peter Parker. Alright, so it's actually pretty common in languages with pattern matching. I think you have something similar in a camel. I'm not sure if you have something similar in Rust, because Rust also enables you with pattern matching, but I think you should put hair in the stream title for... Well, I mean, I did it, and people still were asking, because apparently people don't read the titles. Okay, I'm gonna put the hair in the title. Okay, so cool. So we have this thing, and here's the spam. So here are the words, and then I want to calculate the probabilities. And here's an interesting thing about functions that return maybe. We can use something like map maybe. Then we need a wig. Why do I need a wig? I don't need a wig. It's located in data maybe, which is kind of strange. Okay, I need to make this code compilable, but I cannot, so I'm gonna just put it like that. Okay, so here's the interesting function. It takes list of A's and a function from A to maybe B and returns the list of B's. It's very interesting, in fact. So essentially, it will apply this function to each element and throw away every element that returns nothing. Yes, it's a map plus filter. You're welcome, Jiang. So, because I know the need for this kind of function arises quite often when you program in the pure function style. I forgot the word, the verb for a second. I'm sorry. Arises. Okay, thank you so much. All right. So this is what we're gonna do here. Map maybe probability spam. Right, and as already mentioned, probabilities, we may not know the probability for that word because we've never seen that word before, and we want to ignore it. And because of that, if we don't know the probability, we just return nothing. And by doing map maybe probability spam for words, we can do exactly that quite easily. So, and then we can have inverse probability, right? Inverse probability. And then the probability, the product of all the probabilities. There we go. And then we'll just have to return this formula for the whole message. There we go. That should work. Probability spam should accept. Okay, so word probability spam. Yeah, and goddamn, that's actually very interesting. So that means it has to use a different order for some reason. Okay, so I fucked up the order, but that's not that big of a deal. Oh my god. What's going on? Okay. Spam. I'm working on a spam filter and I'm literally receiving spam as I code. Nice. Oh shit, that's funny. Okay. So, and in here, I can just do something. So I need to finish that spam filter as soon as possible because I'm already receiving spam. It's unbearable. I need it right now. And also this thing doesn't have to be IO. Finally, we've done it. We've fucking done it. Okay. So I wonder what's gonna happen. So now we are ignoring the words we've never seen before. So, and I wonder if it's gonna help with our classifier. So, okay. So text probability spam. We'll have to provide the model, the spam model. So where is the spam? So I can do something like SM spam model. I'm gonna create the spam model. Here it is. It's the spam model. So then I can take the probability of this thing being spam, and it's spam, and it still does this shit. God damn it. So that means at some point these things. Oh my god, it literally just doesn't work. Okay, let me try to debug all of that. So here are the words. Yeah, it's. Then we can take maybe probability. Variable not in the scope, because I have to. Yeah, I have to take this thing. I'm gonna just quickly troubleshoot step by step. So here are the probabilities. It always returns probability either 1 or 0. This is so strange. Is it because the float doesn't have enough precision? Is that the reason? It could be the reason. Maybe we have too many words. What if we replace float with double? Right. What if we just use double? It feels like maybe float just simply doesn't have enough precision to do that. They're very, very low. Okay, so SM spam model. It's still not really work. Doesn't really work. Like, why this? What do I even do about it? Do I just need more data? Is that what I need to do? Do I just need more data? Maybe that's what I need. So maybe this amount of data is just not enough. Okay, let me take a look at the. So here's the spam model, right? I can do spam bowl was it print? I forgot what was the name. Summary ball. Summary ball. Okay. Yeah. It is very, very low. And maybe that's what affects it. Can we have like a bigger text? Okay, let's try to find more text. We could try to debug one word manually. They are present only in ham and spam. That's well, yeah, they're probably present. Okay, so for example, hello, right? If I take a look at the word hello, text probability spam SM. Word probability spam is 1. Word probability spam. So it accepts. It's very low. And what about ham? It is actually 0. Integer arithmetic somewhere? I don't think so. So here's the hello, right? So and this thing divided by 1, since it's present in, we just literally don't have enough data. That's the problem here. We literally don't have enough data. Let's try to find more data. So there's also this thingy. Do they have enough data? Oh my god, why is this so slow? So examples. Okay. Email, spam, ham datasets. So I need more data. I need more data. Spam classifier I'm using. Okay. Spam datasets. Which are the best spam datasets? Okay, spam classifier. So there's this email archive, the preprocessed form, errand spam, ham messages. Okay, it's back. Okay, so we do have something here. This is a spam in preprocessed form. Let's take a look at this thing. Let's take a look at some of this. We need some spam. I can forward my spam folder to you. Thank you very much. Okay. And let me see. Okay. RFT back as. How many of them do we have? That's actually 2004. Look at that. That's a lot of. Okay, that's cool. Maybe that's exactly what we need. Also, let me check. So back S. I hope there will be nothing like MoonKTOS there. Let's try to unpack this entire thing. Hopefully it's not gonna blow up in my folder. Back S. Promotions. Let's take a look at some promotions. It's gonna be. What's that? So it contains the stuff. So we have to parse the format, right? We have to parse this format first. But maybe we don't care. Yeah, I think we have to care. So we have to preprocess all of this stuff. So they do have the preprocessed form, right? Spam in a raw form. Okay. But unfortunately, we don't have a ham. So what we can do is essentially maybe we can try to generate like ham messages, or maybe take like a huge body of text and just say this is ham and split it into small pieces. So something like that. All right, so let me take a look at the cleaned up version. Maybe the cleaned up version is actually better. So here is the cleaned up version. Enron in enron 1 txt. Oh shit! What the hell is going on? Enron. Come on. All right. How many of them do we have there? 5,000. Okay. Cool. FWX. Just extract everything. I cannot properly do that. Okay, so this is... Oh, they both contain ham and spam. Oh shit, I think this is actually cool. So... there is a lot of data. Okay, so... yeah, like we have a lot of data here that we can just use. Cool. Oh shit. All right. That's a lot of data. Okay, let's actually download all of that, because we only had like 100 messages, but here we have thousands in a single archive. So yeah, so now we have way more data. We can, yeah, so this is actually pretty big data. Not really big data, you know what I mean, if you know what I mean. So in readme, maybe I'm gonna actually replace this reference, because this actually turned out kind of useless for us. We're gonna use this, yeah. For this data. Okay, so let's try to download all of them. So let's remove these things. Cool. Now, is there like a quick way for me to download all of that? So if I take the second one and copy paste it here, okay, there is the same, and we have 6 of them. 1, 2, 3, and that means I can do something like 3, 4, 5, 6, and then I can do wget and simply like that. So I'm gonna go to the data, and this is how we're gonna download all of them. Downloading everything. Magic of Bash. How about that? It didn't download the last one. It's coming. It's coming. From Integral, what is your question? From me, or whatever your nickname, I don't know how to pronounce it. What is your question? Like, you didn't ask a question to answer at all. Like, you're trying to ask something, but nobody understands what you're trying to ask. Alright, so, yeah, what do we have here? Eron 2, Eron 1. Yeah, we'll have to, like, you know, unzip all of that manually. Oh boy, okay, so, cool. Let's unpack all of this shit. Now I need to... Some people just live in their own world, what can I say? They just live in their own world, and they're speaking with, like, their own creatures there. What can I say? Okay, so here's the ham, and I wish I could quickly copy-paste everything there. Hence, integer arithmetic, there is no integer arithmetic there. because that wouldn't compile. Finally, you asked a proper question. That was so difficult. Okay, from integral. All right, so let's take a look at it. From integral. Look, we are supposed to return double. If there was integer arithmetic involved, it wouldn't compile, first of all. It just wouldn't compile, right? And let's take a look at the from integral function. What does it do? We should start up a little bit faster, okay? It takes an integral type and returns a. So, and the way it works, along with the type inference, if you try to do something like from integral and put an integer here, it's not really going to compile, and it will return you like whatever type, it will return you a number. But what's interesting is that if you force the type to be double, it will return you double. And what's interesting is that since we require this function to return double, this expression is required to be double, and that means each individual argument of this operand is required to be double, which forces both of the from integrals return double. That's how type inference works in Haskell. Seriously. So from integral can return you any number constructed from integral type. You just need to hint what kind of type it should return. The way we hinted to return double is by saying that this function returns double and everything else is done by type inference. Does it make sense? So this is how it works. Welcome to Haskell. For example, if you have an integer, right, I can even force it like that. So here's an integer, right? This is integer. And you have another integer, like this. And you apply from integral on both of them. And you divide one by another. I'm simulating the situation we have in the code, and then I force the whole expression to be double. Make sense? All right. So we need now to put all of this data into the training set. So here's the train, and so this is errand 1. So I'm going here, then I go here. Oh boy, I wonder, can I just copy paste this stuff there? All right, let's just try to copy paste it. So I'm located here, right? And I'm gonna even do it like that. And I want to copy paste it. So one back, train ham. I'm gonna leave it here. I think it's gonna be important. So maybe it also makes sense to move it. Cool. And now, how many files do we have here? We have 3,000 files. 3,000 files. As an opposite to 50 of them. And this is only one archive. This is only one archive. So maybe we're gonna get along with just one archive. Alright, spam. So we have 50 of this thing here, and we have 100 and, okay. So we have to move that to spam. Okay. Oh boy, oh boy, oh boy, oh boy. Oh, I can get really lost super easy. I don't like that. So this is empty. This is also empty. Okay, then the train spam should contain, yeah, it should contain several thousands of them. All right, so, and here is the, cool. Okay, so now instead of like 50 emails, we have thousands of them, and only from the first archive, which is already good. So if we're not gonna have enough data, we can add another archive, because another archive here contains another thousands of hams and another thousands of spams. Okay. So let's give it a try. So I'm pretty sure it will take some time because the model is way bigger now. So spam ball. Yeah, I need to do SM spam model. So here's a spam model and invalid sequence of bytes. Are you serious? What the hell is wrong with this particular file? Okay, data train spam 414. Oh shit, what the fuck? Okay, so apparently we have a Unicode situation on our hands. We have a Unicode situation on our hands. So how, why doesn't it work though? It's kind of strange. So, all right. So here's the path, because text is supposed to work with, you know, Unicode. So that means if I do something like read file, this thing, it should work, but it doesn't. It doesn't work. Yeah, it literally cannot encode that. It cannot read that file at all. Okay, so one way we can try to do that is by reading the file as a sequence of bytes and trying to encode it with UTF-8 or something. But maybe that's exactly what they tried to do, and they couldn't. But this file looks like a, you know, just a, yeah, it's just some Unicode stuff, so apparently it just couldn't handle that. All right. For that, we'll need a byte string package. That's what we'll need. We'll need a byte string package. So apparently text package is incapable of handling UTF-8 by itself. So we'll need the help of a byte string package. As far as I know, it comes with installation, so I can grab a byte string here. So here it is. We even have base 64 byte string. Would you look at that? The most reliable encryption algorithm of all time. So here's the cabal, and I'm gonna put this. This is not what I wanted. Oh my god. Clipboards in Linux, by the way. Linux has way too many clipboards. They confuse me all the time. What's up, Profiber69? Welcome to the stream. Alrighty, and can we compile all of that now? Yeah, I think. What are you waiting for? It's doing something. What is? Okay, so there's a lot of untracked files, I see. Okay, so all right. Cabal file changed. So now in the text package, I wish this website would work a little bit faster. I just need a documentation for text package, please. I don't need much in my life, just documentation for the text package. I don't ask for too much. Okay, index. Alright. So there was something about encoding. Let me take a look. Encoding. Yeah, encode UTF-8. So this is basically what we're gonna expect here. Actually, it was something like decode UTF-8. There we go. Decode UTF-8. So we accept byte string, right? Decode byte string containing UTF-8 encoded text that is known to be valid. If the input contains any invalid UTF-8 data, an exception will be thrown that cannot be caught in period cut. For more control over use UTF-8 prime. So which returns the either exception. Okay, that's very interesting. But maybe that's exactly what happens. Does read file actually tries to decode UTF-8? That's a good question. Let's take a look at the UTF-8 file. Read file. When you call read file, does it assume UTF-8? Reads a file, returns the content of the file, the string, the entire file is read strictly as gets contents. It doesn't say anything about encoding, so that means that probably doesn't encode anything. Let's do import qualified data byte string as B. Yes, please. No. Oh my god. You don't need. Emacs is dumb. Emacs is super dumb. Okay. Let's restart this entire thing. Come on. I don't know why I decided to take a look at the Magit status. I think it was not a wise choice. Just give me the repo. I'm not asking for too much. Just give me the repo. Come on, you can do that. Just load dependencies, do whatever. Okay, finally, thank you so much. I really appreciate it. Okay, so read file. Yeah, that's exactly what I'm talking about. And let me try to take a... So there was a spam. I lost the file path, unfortunately. Oh, lane repo is just, yeah, lane by itself is the most horrible build tool I've ever seen. Like, the amount of time you have to wait is just, oh my god. And people are okay with that. Spam model. Okay, here's the spam model, and that's exactly what I'm talking about. That's exactly what I'm talking about. Oh, come on. It's too much time. B read file. Okay, is it gonna work? Can I do like B length? I wanna force it. I wanna force it and see that it reads this file successfully. Okay, it in fact reads this file successfully. Now, can I do text decode UTF-8 straight up? It doesn't have decode UTF-8 because it's located somewhere else. It's located in data text encoding. Okay, so we'll have to do import qualified data text encoding st. So we're gonna put everything there. Hello Firefox. Okay, so it is invalid UTF-8. In fact, it is straight up invalid UTF-8. So maybe one of the things we can do, we can try to skip the files that are not valid UTF-8. So this is one of the things we can try to do. Just skip them, because we have an opportunity to do so, right? We can just use decode UTF-8 prime, and it will just give us exception in a pure code. Yeah. So I'm gonna put prime, and as you can see, it just gives us that. Yeah. Doesn't it confuse us with other imports as T? No, it actually adds them to the T. It accumulates all of them. So essentially, I basically import 3 modules into a single namespace, because all of them are related to text. And the only problem may occur if the names between these modules will collide, but they don't collide so far, so it's okay. I guess that's the clever way for spammer to spam. Use invalid UTF-8, break the validators. Lol. Yeah. Okay, so bow from file. So this is where we use the read file. Okay, and this is how we're gonna go about that. So this is gonna be B read file path, and that gives us the bytes. And then we are trying to decode UTF-8 prime bytes and then match all of that. Actually, K is off, and if it's maybe you have to return like maybe, right? Bow from file, because then we can do bow from folder. Bow from folder, and this is going to be right. So this is going to be content, and text, yeah, text to bool text. Otherwise, if it's left, we don't really care about it, we just return nothing. Yep, so let's see if it's gonna work. It actually has to ignore this thing. It has to be just, also return. Yeah, but you know, you can move return to here, it's also gonna work. Okay, so now when we use this kind of stuff, instead of single bool, we have maybe bows, right? So we have a bunch of maybe bows, which we need to filter out. So, and the way we're gonna do that, I think I'm gonna do map maybe ID, which will filter out everything that is nothing, and then we're gonna follow them, and now it works. So essentially what we're doing right now, we're ignoring the files that we cannot read. And the question is how many files we cannot read. So, I don't know. We'll see, we'll see. Okay. So the next thing, I'm going to try to read spam model. Okay, the spam model has been read, and I can take spam bool sm and take a look at the words count for that one. And how many words do we have for the spam? Probably, yeah, that's a decent amount of words. I think hundreds of thousands of words is actually pretty decent, not gonna lie. What about ham? For ham, we're probably gonna have even more. Yeah, so I think this is a decent amount of words. What do you guys think? So if we're not gonna have enough of that, maybe we're gonna add even more. But so far this looks promising. So now we can just try to do word probability spam, and let's take a look at the word hello. What's the probability of word hello being spam? That's already something reasonable. That looks like a proper probability. Like 86%, actually 87 if you round it properly. Yeah. That's already fucking something. Okay, so now we can try to do text probability, right? So how do I apply that? So it accepts spam mail first, and if I put hello world here, excuse me, oh, it has to be text. It's a 90% probability of this being a spam. Okay, so I want to take this message, right? I want to take this message and I'm going to put it here, and let's see how probable it is it's a spam. It's 100% spam. It's 100% spam. That's very strange. Spam mails. That's really strange. Why is that 100% spam? So that's kind of strange. So let's take a look at some other messages. People don't say much. It's just so funny. The whole chat is filled with you know, hair copy pasta because people keep asking it. Yeah, so that's actually less likely to be a spam. Okay, so let's take a look at some other things. Maybe this kind of text. This kind of text. This is totally spam. Huh. It's really strange. It's trying to do something. Consider spam. Okay, let's see. Chat is cute. Yeah. It is totally spam. Yes, it is totally spam. That's really strange. Like, why is this? Maybe we need even more data. Maybe we need to add another archive there. Oh, by the way, we have a validation set. I completely forgot about validation set. Yeah, I completely forgot about that one. So this is something that we can try to now apply to, right? Because they're a little bit closer to what we're trying to do here. Yeah. Let's do the validation. So validate. Yeah, let's do something like this. Check folder. Check folder. Maybe we're gonna start with the check file, right? Let's do it with the check file. It's gonna be file path, and it will return us a probability, right? It will return us a probability. Then we'll have to read file. So I think I'm gonna extract this reading mechanism. Read file if possible, right? It accepts the file path and returns IO, maybe ttext, right? We just do something like this, right? So we read the bytes, then we try to do that, and we simply return the text. So I'm pretty sure there is like a way to turn either to maybe. Is there any like standard way without installing any third-party dependencies? Is my internet dying? Okay, it's not dying. Either A, B, maybe B. Can you do something like that? Is it possible in standard library? Please tell me it is possible. Write to maybe and it's not standard. Thank you very much. Okay, so bow to file, and essentially we can read the contexts. Text to bow. Contents. Read file if possible. File path. And then I'm gonna return text to bow contents. Cool. Is it gonna compile? It does not compile, because why? Because I have this text. Does it compile here? File path. Okay, file path. There we go. Cool. So read file if possible. What is going on with the Twitch? Is everything okay? Left to maybe, right to maybe. Not a standard way. Alright, I already talked about it. So read file if possible. Check file. Cool. But maybe in this particular case I want to just throw an error. So T read file is going to be file path. Then text probability spam. This one has to be double, by the way. So we have to provide a spam model as well. So this is a spam model. Text probability spam. Text probability spam. Wait a second. But what's the probability? I think just because the probability of it being a spam is 80%, does it mean that the probability of it being a ham is 20%? Oh shit! It doesn't mean that. I think we need an opposite function called text probability ham. Oh shit, okay, and then we can basically have some sort of a threshold. First of all, we can check if the probability of ham is bigger than probability of it being a spam, and then we can also have a threshold on top of that, and that would be actually more accurate. You see what I mean? You see what I mean? Yes, yes. Oh my god, I didn't think about that for some reason. All right. So, and yeah. So, but for that we'll need first of all the function like word probability ham, right? So word probability ham, and encounter the same error every day. I should have seen this coming. So is that a common mistake that people do when they work with this kind of thing? It feels like maybe it is. Okay, is the probability of being a spam, probability of being a ham. So essentially what we do here, we just reverse this to PHS and then to PWS, and that gives us the probability of this being a ham. Yeah, I think they're not contrary. Yeah. So I don't think they're contrary. So, and instead of this kind of stuff, so text probability spam, this is, yeah, and similarly, we can change it to ham, and this one is also going to be ham. Like we have a little bit of a copy paste. Hello MM2PL, welcome to the stream. But I think I'm gonna have a function classify text spam model, then we have a text, and it should return double. So first one is going to be spam, the second one is going to be ham. So, and this is the text, and essentially, yeah, we can do it like that. Text probability spam, so the first one is a spam, and text probability ham. Speaking statistically, they are not independent variables. Well, yeah, but I think we're using independent theorem, but we'll see. I just want to see what's gonna happen. Okay, it does compile. So SM spam model. Here's a spam model. We read it successfully, and let's try to classify text hello world, and let's see the probabilities. The first probability is a spam. Let me double check that. So spam uses probability spam, words spam. The second one is ham, right? And ham uses word probability ham, and in word probability ham, these things are simply inversed, nothing special. Oh shit! Oh, we're up again. We're back again. Refresh your page. I don't know what happened, but I just dropped some frames. I really apologize for that. Okay. Spam model. Okay. Okay, it's calculating the probabilities, so it's gonna take some time because it needs to like warm up and okay, so the probability of this being a ham is actually pretty low. Hello world test. Okay. Huh, that's interesting. So the probability of this being a ham actually goes down. Okay, so what about hair? Okay, let me try to do that one more time. Chatterino doesn't work properly with clipboards. Okay, let's see. So, oh, it's kind of interesting. All right. So that does make sense. Maybe we just need more data, but yeah, I wish. Yeah. So I actually got sidetracked yet again. What I need to do here is check the file, right? Check file. I was working on that. And classify file. Okay, let's do classify file. It's annoying that it doesn't set the selection clipboard in X. Yeah. Okay, so this is the file path, and this is what we're gonna return. So double. Okay, and here's the file path. So t read file path, and I'm redirecting that to classify text. And this one is SM. Is it gonna compile? It does not compile. Because why? What's wrong with that? What do you want? What do you want? Okay, so I think we have to do it like that. Okay. Cool. Whew. Now, we have the model. Let's try to classify things that are known to be spam or known to be ham. That's what we're gonna try to do. So we have a special folder here to validate things. So here's the ham. Let's go here and I'm gonna go classify. Thank you, MindSpike. Thank you. So we're gonna classify a file, I think. So this is what we're gonna do. So here's the ham. Here's a little bit of ham, and here is a little bit of that. And it didn't. Okay, so that means I need to do something like spam model. Yeah. And I have to provide it here. Okay, it's trying to classify the well-known file to be ham. Let's see how it goes. No, it's still considered spam. What about something that is known to be a spam? How about that? Okay. And it's also slow as fuck. Actually, it is 100% spam and probably 0%, yeah. Huh, to be fair, if you have like a pretty... To be fair, for spam, it says 100%. Look at that. For the spam, it says 100%. So here's the second file. Yeah. So what I'm thinking, maybe... For the ham, essentially you just have to have a particular threshold. Yeah, I think that's what has to happen. So for the ham, it has to be a particular threshold. So for the hams, it's usually lower anyway. Look at that. Everything actually is a spam. Oh shit! Look at that. Second was confirmed to not be a spam. That's very strange. Look at that. Yeah, it's completely ham, and it is in fact ham. So I have a hypothesis that on average, hams are just gonna simply have less spamminess, but spams are gonna be 100% always. I think that's... yeah, oh, there we go. Okay. So what about the fourth one? Yeah. Shit, I think it's working. Oh fuck. It's fucking working. Can you retry first ham? I can retry first ham. I think the first ham is kind of like suspicious. This is... yeah, it is really sus. It is very sus ham. Okay. It is a super sus ham. Yeah, so it's very suspicious. Okay, so you know what I want to do now? I want to automate that. I want to just iterate through all of the ham files, like ham validate files, and all of the spam validate files, and look at their statistics. It's gonna probably take some time, but yeah, we'll see. If we can reliably detect that these files are spam and these files are ham to some degree, it doesn't have to be perfect, I think I'm gonna call it success. Bash script, I mean, we don't really need a bash script because we have list directory function that basically accepts the directory and gives you the list of files. You don't really need that, so we can use something like that. So we can classify file. Okay. What is ham? Ham is something that is not spam. Yes, I know, it's very funny. So it's a funny joke. So and it's a real terminology in this area, by the way. People who work on spam filters, this is their terminology. They call ham something that is not spam. So ham is something that you want, and spam, this is something that you don't want. So all right. So what do we have here? Classify file. Maybe let's call it validate. Validate file. I have an idea. Classify folder. Right. You get a spam model, then file path for the folder, and I don't know. yeah, I think we're gonna do some sort of a summary, and this is gonna be a spam model. Folder path, right? Then we're gonna have file names, list directory, folder path, and this is where we can iterate all of them. So it's gonna be something like this: file names, file name, and stats, classify file. And how we're going to classify it? We're going to take folder path slash file name. Maybe I'm going to call it let file path, like this. This is a file path. Classify file path, and then we're going to printf this entire thing. It's going to be printf s. So file path stats, but stats has to be shown like this, and this has to be a new line. All right, so this is basically what we have here. We classify the folder, and it will, yeah, this will just do that for me. Classify file accepts this kind of thing. I mean, this is real world Haskell for you. What do you want? Classify. Oh yeah, I need to do sm spam model, and classify folder. This is going to be ham, and get ready. We're classifying the first file in the ham folder. Actually, this is not the first one, but it's one of them. I wonder how much time it will take. It takes a lot of time because maybe the file is too long. Who knows? But it's definitely the ham. Maybe you don't want to do this kind of things in text has a snok function. Oh, it's like opposite of cons. It's like opposite of cons. So far it works. I think these ham files are too long. That's what it feels like. Not all of them. Some of them are fast. But so far it classifies them more or less correctly. It's just too slow. That's the only problem we have here. Multi-threading when we can try to do that. Yeah. Imagine using OF and lookup instead of log entry map. Well, oh shit! It's killing my PC. I think I cannot control Emacs anymore. Emacs is dead, by the way. I wonder if the stream is still alive, but. By the way, is the stream alive? But Emacs is dead. I don't know why is it so dead. Okay. That's strange. I think Emacs is just, you know, going crazy. I don't know what the fuck is going on. Okay, this is one of the things we can do. Spam model and classify folder sm, and can I do something like data validate ham, and maybe in here it will work a little bit faster, or at least it's not going to be dead super soon. Yeah, but to be fair, I think this is a success pretty much. We're capable of validating them. Is just generally too slow, and I'm not even sure how can we speed it up, but yeah, that's pretty cool. That's pretty cool, not gonna lie. Interesting. I don't understand how it works, how this entire formula works, but it works somehow. It classifies the ham as ham so far. XKCD, what is that? Compiling. Well, we're not compiling, we're waiting, we're validating our model, that's what we're doing. Did you cut your hair only with a clipper or with anything else? I actually used razor blade. Okay. All right, I get it. So what about spam? What about spam? Can we classify reliably spam? Yeah, so it classifies the spam pretty reliably. This is success. We lost like 20 people, but this is still success, I think. It's slow, right? But I think speeding this thing up is a completely separate task. And I'm not really sure why exactly it is slow, but it reliably classifies the spam and ham. At least like for 3, yeah. You see, it reliably classifies them, and that's kind of cool. Yeah. Works. So yeah, this is success. I'm calling this a success, even though it turned out very slow. But I think making it faster has nothing to do with the original goal of learning how to do this kind of thing. Yeah, so I'm gonna just go ahead and commit whatever we have. I'm not gonna commit the data. Oh shit, the data, like there's a lot of data here that is not really wanted. So what I need to commit here is main HS. Oh shit. Oh my god. Okay, I need to have too much data. Okay, let me remove the data folder. I'm literally removing the data folder. So then, so there is this thing, and there is that thing. So, and everything else can be discarded. So, no, Emacs, just fucking, what the fuck are you showing me? I don't want to see that. Alright, I just want to double check. Working with a lot of data in Emacs is huge pain in the ass. Oh my god. Okay, so here's that, alright. First implementation of the classifier, final working implementation of the classifier. I wish like I could commit all of the data necessary for it to work, but there's just too much data, it requires too much data. So I cannot really commit that, but I think it is working. It is just fucking working. I think that's amazing. Yeah. So, and you can find the source code of this thing here if you're interested. I did my best to implement that. The only thing that I used to implement, to like understand how to implement that is these 2 articles, I think. Oh shit, I'm an idiot. I should have actually... my references are so bad. So this is not what I wanted to replace. I wanted to replace it like this and then like this. So yeah, the only 2 articles that I used are these 2. So they're gonna be available in the reference in the source code, but the main one is this one. Right. So that's cool. Fix references. I'm gonna push that right into the repo, and again you can find the source code here if you're interested. Alright, so you guys wanted a little bit of Haskell? There you go, here's some Haskell for you. Unfortunately, I didn't really have time or energy to do Advent of Code, So we're gonna do Advent of Code tomorrow first, right? So we're gonna solve day 10 and maybe then day 11. We'll see how it goes. But unfortunately, it is time for me to go, boys and girls. I hope today's stream was interesting. It's kind of difficult to make such streams interesting because we're talking about, like, you know, very mathy topic, which people are very scared of, and also using mathy language, which again people is scared of even more. But I hope for those of you who are interested in these kind of topics, it was interesting. But unfortunately, it is time for me to go. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you tomorrow. Tomorrow, according to the schedule, we are doing game development in C++. We're going to continue developing our game that we've been developing for a year. Also, check out the schedule for more information on different projects we're working on. We're working on several projects simultaneously on the different days. And also check out our votes channel where we archive our streams. This stream is going to be there, but tomorrow we upload them on the next day. And also check out our Discord server for offline discussion with the community. And that's it. That's it for today, boys and girls. Love you all.